Hello, everybody. I'm Nick, the old Raging Cajun. So before we get started, a little early in the morning, before we get started, let's go get a big cup of coffee. So today we're going to talk about LoRa radios. So we're going to have a transmitter talking to a receiver. And here's the big picture. Oh, by the way, guys, this is called a concept or a level 0 drawing. So we got a radio transmitter, a LoRa radio transmitter talking to a LoRa receiver, right? And on each end, we got it hooked up to a microcontroller. In our case, it's a SHAL, but it could be Arduino or anything. Maybe an STM for some of you guys. So this is a big picture. Now let's go get it wired up. So we come over here to the wiring diagram. So here we have, let me try to center this a little bit. So we have a LoRa transmitter, LoRa receiver, and a microcontroller, in our case a SHAL. Now let's zero in and make this a little bigger so you guys can see it. So this device communicates to the controller, or what we call an SPI bus, serial peripheral interface bus. And it's got 6 connections. So the first thing we do is we have this pin over here, which is called a MISO pin. Master in, serial out. So it's got an in there, which means it's going to take some information from the controller. The next pin is the counterpose to it, master out, serial in. So it's going to output, and of course the S means serial, means it's going to come bit after bit. So the next connection is a clock connection, which is right here. All right. Now, because this is a synchronous connection, we need to have a clock. All right. And the 2 other pins we're going to talk about is the chip select. Now, on all SPI devices, we have to have what we call a chip select pin, which needs to be low when we're actually communicating between the controller and the device we're talking about. And the last pin is a reset pin. All right. Now, in this drawing, let me kind of recenter this thing. We wire all this up to our controller, and for example, the MOSI pin is connected to pin 11, right? The MESI pin is connected to pin 10s and so forth, all right? And here's our chip select and our reset pin, all right? Cool. All right, now let's get to the code. So where's my code? All right, so this is the transmit code. And if I can move my cursor around, it's pretty simple. Look, it's only about 30 lines, something like that, right? All right. So now let's start. So the first thing we do is we're using libraries, all right? So when we use libraries, we gotta tell the controller where to look for. Well, we choose, in our case, to put the library in the same directory as the INO file, all right? You don't have to do that, but in my case, I choose to do that. And the way we tell it to go look over here in the same directory is, instead of these greater than and less than symbols, we use quotation marks. Right? So let's go look at this library. Right? So this library is where we tell a lot of things. So remember, we had a chip select pin, and in this case, it turns out to be in pin 7. In your case, it'll be pin 4. Right? And we have a LoRa reset, which we put on pin 3. So this is in this LoRa.h file. Now let's get into the main code. Right? So the first thing we got to do is we got to tell it, look, we're going to use SPI. The way we tell the Arduino that is we use an include statement. All right? And then we also tell it where the library is, and we use the include, and we use the quotation marks. Now let's get into the main loop. So on almost all controllers, especially if we're going to hook a terminal device on it, we got to tell it that it's a serial, and we do this in Arduino code with a serial.begin. In our particular case, the SHALs only work in 11,500, or excuse me, 11,115,200 bits per second. And because that's a slow device, we use this little while statement to let it get up to speed. And when that damn thing gets up and running, it says, I'm ready to go. Lloyd, Prince Laura, sender. Right? Now the next thing we got to worry about is we got to tell it which frequency it's on. The way we do that is with a command called LoRa begin. Right? And this statement, if it comes out false, it says we got something wrong. And we print out LoRa failed, and this while stops the execution. So if you get that, you got an issue. Go figure out what you did wrong. Now let's get into the main loop. Look, pretty damn simple. So the first thing we do when we get in the main loop is say, look, it's sending a packet. Big deal. We're also going to count the number of things we send, so we print the counter, and down below we'll increment that counter. Now, the meat of the program. It really only takes 3 statements to make the transmitter work. The first thing you do is you say LoRa.begin packet. The next thing is you say LoRa.print. And look, here's a string. In a string, we choose it to say hello, but you might want to change that out to your data or a message or whatever you want. All right? We print the counter. We want to count how many times we sent it. And then the last statement is in the packet. Big deal. Look at here. We wait 5 seconds and start the whole press over again. I don't know if you can see it down here, but it's actually printing as we go. So now let's go talk about the receive side. All right? So let's go get the receive code. So here we go with the receive code. We've got essentially the same thing. We go over there and we tell it which frequency on. We actually see if it's working. If it's working, cool. Now here's the difference between the transmitter and the receiver. So the receiver in this method continually checks to see if it's got data. Right? And the way it does that, it says if packets, in other words, if that thing is valid, right, it's got a receive packet, and it prints out to our terminal it received a packet. Now here's where we actually capture and print the deals. So this statement, this while statement here, it says while there's bytes in that buffer with this statement, LoRa.available, we print and we read and print the characters. So the characters come one character at a time, and we read them and print them. When we get them all done, this thing comes out of this while loop, and then we want to ask how strong was that signal we just got. And the way we do that is we interrogate and print this packet saying read or give us the RSSI, which stands for Receive Signal Strength Indicator. Right? And that's a number that is typically between minus 120 if it's a weak signal and minus 80 dBm if it's a strong signal. That's the story, guys. Look how easy this is. Now, of course, like Paul Harvey said, there's the rest of the story. And actually, all the hard work is done in this file, LoRa.cpp. Look at here. This is a 600-line code. And if you want to understand that, you got to go RFM. Read the frickin' manual. It's only 150 pages. I encourage you to do that. So guys, this is the story, the LoRa story. Go wire it up, hook up with it, play with it, try to understand what's happening. And if you need some help, give me a call.